Hello, everybody. Happy Monday if you're watching this on Monday. Hope you had a great weekend. As you may have guessed from this prep assignment, this week 2 prep on Newton, this week is all about matrices. Woohoo! I know some of us have not seen matrices before, and that's all right. Some of us have, and you'll be a little more familiar with matrices. Matrices are super helpful for a lot of different mathematical concepts. We will look at them first through the lens of solving systems of equations, which we will do today. Today's lesson consists of actually two lessons, 6 and 7. So after you are done watching this lesson 6 video, go on over and watch lesson 7 as well. Just a reminder, if you're watching this on Monday, then tonight at midnight, you will have a recitation assignment open up on to Canvas, and it will be due on Tuesday at midnight. So don't forget about that. I will send out an email reminder about that to remind you. All right, so let's get into matrices. What is a matrix? Well, it's basically just a box with numbers in it that represent different values for different numbers. We are going to use them, like I said, in systems of equations. So a matrix can serve as a device for representing and solving a system of equations. It actually can represent a lot of things, but this is what we're going to do first. To express a system in matrix form, we extract the coefficients of the variables. The coefficients, those are the numbers in front of x or y. And we also extract the constants, and these become the entries, or the numbers, of the matrix. We use a vertical line to separate the coefficient entries from the constants, essentially replacing the equal signs with this vertical line. When I have something like this, we call it an augmented matrix. So how do we write a matrix in augmented form? Well, we first write the coefficients of the x terms as the numbers down the first column, that's a vertical column, of the matrix. Then I write the coefficients of the y terms as the numbers down the second column of the matrix. If there are z terms, which we will have sometimes if we have 3 equations, we write the coefficients as the numbers down the third column. Then we draw a vertical line and write the constants to the right of the line. So let's do an example. I want to write the augmented matrix that corresponds to this system. When we draw matrices, we either put all the numbers in these brackets or in big parentheses. I like to use brackets, but parentheses work too. And the first thing we do is write the coefficients of the x terms as the numbers down the first column. So here I have a 3 in front of this x, so I put this 3 right here. I don't include the x, I just include the 3. Then I have a 4 right here, so that will go as the second number in my first column. That's step 1. Then I do the same thing with y. So here I have a 7 in front of this y, that will go here. And I have a -2, important to note that negative sign, right here. Since I don't have any z's in this system, I'm going to draw a vertical line, and then to the right of the vertical line I put these two numbers. So here I have a 7 and a 5. And this is an augmented matrix. It's important to note that this matrix represents exactly this system of equations. It's just another form of representing a system of equations. So they're pretty cool. Next, we want to write an augmented matrix that corresponds to this system. Here, I see that I have a couple of z's, so I'm going to have 3 columns before my vertical line. So that's important to note. So we draw these little square brackets. And first I look at my x's. So here I have a 3 in front of my first x. Here I have an invisible 1 in front of my x. And here I have a 2. Those are my x's. Next up we have our y's. Here I have a -1 in front of the y. Here I have a +1 in front of the y. In this third equation, I do not have any y's. So I'm just going to put 0 since I don't have any of them. And we move on to z's. Here I have -1. Again, really important to remember that negative sign if there is one in front. In the second equation, I do not have any z's, so I put a 0. And in the third one, I have -3. Then I put my vertical line, and I put the numbers on the right, 0, 5, and 2. So in these first two examples, we went from equations to matrices, but we can also go in the reverse direction, from a matrix to a system of equations. And that's what we want to do in this example. So we want to write this system of equations given the augmented matrix that represents it. So I know that these represent my x's. So maybe if we go backwards, we'll write all of our x's first, then all of our y's, all of our z's, the equal signs, and then the numbers on the right. So I will have 4x in my first equation, x in my second equation, that's the 4 and the 1, and then 0x in the third equation, so I'll just leave it blank. In the y columns, I have negative 3y, nothing in the second equation, and then I have 8y in the third equation. Finally, I look at my z's. In the first one, I have plus 2z. In the second one, I also have plus 2z. And in the third one, I have plus 5z. My vertical line represents my equal signs. And I have the first one equals 1, the second one equals negative 9, and the third one equals 11. So it's really handy to go back and forth between equations, like we just wrote, and matrices. So we can go back and forth. Both of them tell us really useful information. So there's a particular form of an augmented matrix. It's called a row echelon form. We will learn more about this later on. But a row echelon is special. It has a diagonal form, which means that it has, a special diagonal from the upper left corner to the lower right corner made entirely of ones. So we have an example down here. So a row echelon matrix has this diagonal right here consisting of ones from the upper left corner to the lower right. And below that, I only have zeros. So we can see in this example, below our ones, we only have zeros here. So what is this special kind useful for? Well, we can work backwards now to solve the systems of equations. So let's do an example with this row echelon form. Again, we know that it's a row echelon form because I have a diagonal down the middle of ones and zeros below that diagonal of ones. So first, let's write a system of equations. The first equation, well, let's do our x's first actually. So in the first one I have 1x, and in the second two I don't have any x's. In terms of the y's, I have plus 5y in the first equation, y in the second equation, and nothing in the third equation. And in terms of the z, I have minus 6z in the first one, plus 2z in the second one, and z in the third one. Then I have all of my equal signs, and I have 1, negative 3, and 4. So we want to find the solution to the system of linear equations, so I want to solve for x, y, and z. Well, the reason, as you may see now, the reason that row echelon form is so handy is because we already have one of our variables solved for. I already have z solved for. So that's why this is so handy. Because of this last row right here, it already solves for our last variable. So now that I have z solved for, I can plug this z value into our second equation to solve for y. So I can plug this into this equation. So I will get y plus 2z, but z is equal to 4, equals negative 3, or y plus 8 equals negative 3. Subtracting 8 gives me y equals negative 11. And now I can plug z and y into the first equation to solve for x. So that's what I'm going to do. So I have x plus 5y. X plus 5 times y, which I just found to be negative 11, minus 6z, and I know that z is 4, equals 1. Okay, so I get x minus 55 minus 24 equals 1. I can combine these two things, this one and this one. So I get x minus 79 equals 1. So if I add 79 to both sides, I get x equals 80. So my solution here is x, y, z equals, my x value is 80, my y value was negative 11, and my z value was 4. So this is my solution here. So we did this by expanding, basically, our row echelon form of the matrix. We rewrote this in terms of a system of linear equations. And then because our row echelon form was so handy and I immediately knew what z was, I went ahead and I plugged in these values into the other two equations to solve for x, y, and z. Pretty cool, huh? I think so. All right, so that is it for this lesson, but like I said, pop on to lesson 7 for the next one. I will see you there.